Hello class, so today we're going to be going over lecture 12 and this is for chemistry 10. So for all my nursing majors out there, this is going to be really useful for you. So what we're going to be talking about today is basically reactions and basically like what they do and how we can define each reaction based on their name. So as you see right here, we have combination, decomposition, single and double replacement combustion reactions. So let's start with 1A. So what does 1A look like? Well, first we got to know what these kind of reactions mean. What does it mean for like a combination, a decomposition, or a single double replacement combustion reaction? So for 1A, hello class, so today we're going to be going over lecture 12 and this is for chemistry 10. So for all my nursing majors out there, this is going to be really useful for you. So what we're going to be talking about today is basically reactions and basically like what they do and how we can define each reaction based on their name. So as you see right here, we have combination, decomposition, single and double replacement combustion reactions. So let's start with 1A. So what does 1A look like? Well, first we got to know what these kind of reactions mean. What does it mean for like a combination, a decomposition, or a single double replacement combustion reaction? So for 1A, we see that we have chlorine, Cl2, and it's a gas, which we don't really need to focus on. So we also see that it's plus to 2 potassium and iodine. Now we know that chlorine, get a little close here, chlorine is basically our anion, and for potassium, we already know that it's our cation, because the cation has a plus and an anion has a minus, right? And for iodine, we have, it's going to be an ion containing a negative charge to it. So what does it mean for an anion, a cation, and an anion? Well, when going from the reactant, this is going to be reactant, R is going to be reactant, P is going to be product. From going to reactant to product, we're going to see a shift and change. So, because, and I'm just going to go ahead and put parentheses over this, so you know what this means. Okay. We're going to basically go to now the product side. So we see that potassium is now with chlorine. And we know that potassium is a cation with a positive charge. Now, why is potassium now linked up with chlorine? Chlorine was the anion. And then why do we have iodine alone? Well, this is what we call a single replacement reaction. And I'm going to tell you why it's a single replacement reaction. As you see, I have written over here, I have 2 KCl plus iodine gas. Now, I basically just wrote what was right in the product side, just down here, just to show you exactly the shift and change. So, we have potassium, and potassium's our cation with a positive charge, and our anion with a negative charge, but for chlorine, plus iodine. So what does this mean when we have K as our cation swapping with Cl, or anion? What does it mean when a cation swaps with an anion? Well, when that happens, we call that a single replacement reaction. So this is going to be first reaction. This is called a single replacement reaction. And you're probably wondering, well, why is iodine alone? How come it doesn't have a cation with it? Well, for this problem or example, we do not have a cation in the very reactant side in the beginning. We don't have a cation with chlorine. So because of that, you're not going to have anything that goes over to the iodine side. It's just the potassium, or the K, going to the chloride side. And that is your single replacement reaction. Okay, now moving forward, we're going on to 1B. So as we see in 1B, we have nitrogen gas and hydrogen gas equaling to 2 nitrogen-hydrogen gas molecules. So the first question is, what is it going to be? Well, we know it consists of nitrogen, which is a non-metal, and then we have hydrogen being a metal. So what does that technically make it to be? Well, for this one, it's actually very simple. It has not anything to do with a metal or non-metal. It just has to do with what the product is. So as we see, we have in our reactant side, in our product, in our reactant side, we have 2 elements, and we see that it goes on the other side to making 1 combined element or compound. So what do we call a reaction where it's 2 elements combining to 1 compound? Well, we just kind of said it, right? We said combining, right? So it is combination reaction. So that is the answer for 1B. So now let's go to 1C. 1C, we know that there's again 2 elements in the reactant side, and we also have 2 elements in the product side. So what are the reactants? Well, we have carbon, hydrogen, oxygen with 6 oxygen gas molecules equaling to carbon dioxide and water gas. So what does this mean? Like, what kind of reaction is it? Well, we know for 1A we got our single replacement reaction because there is a cation and an anion. We know for 1B it's going to be a combination reaction because we have 2 elements combining to making 1 compound. So what is going to be of 1C since we have combination and also single replacement reaction? Well, anytime you have in the product side, this is actually a very easy problem. Whenever you see in the product side that you have, as a result, carbon dioxide and water gas, that is going to be a combustion reaction. Your key elements right here: carbon dioxide and water gas. Always needs to be in the product side, so on the right side, in order for it to be a combustion reaction. And that is how you know it is combustion. So anytime something goes like kaboom or something like that, you know it is resulting from a combustion reaction. So last question for 1D. We have 2 nitrogen gas molecules in the reactant side. Let's just put R for reactant. And it equaling to nitrogen 2 gas. And it is adding to oxygen gas. So we got, for as far as choices, the first one was simple replacement. For 1B, we got combination reaction. And for 1C, we got combustion reaction. So for 1D, as you can notice, it has 2 nitrogen-oxygen gas molecules. So what is it called when you have 1 single compound decomposing into 2 single elements of its original parts? Well, we just kind of said it. Because of the breaking down process or the decomposing process from reactant to product, a single compound to its single elements, or excuse me, a single combined compound into its single elements, we can call that decomposition. Reaction. So that is how you can tell what type of reaction based on what kind of chemical equation that is given to you in Chemistry 10. Thank you.